and I'm gonna have to look that way a lot because she has my computer. And so without it, I have no idea what I'm gonna say. Well, I usually have no idea what I'm gonna say anyway. So where do we start? I really was. I was 17 years old when my brother, I say a lot when my brother and I started Gas and Street Service, and we did start it together, but I worked for him. You know, he was 22 years old. He was an old guy and had been doing it a whole lot. Our family were friends of the Saps. And so he went to work for Saps Tree Surgeon, and after he did, then when I turned 17, I went to work for them, and so yeah, now we're tree guys. And over the summer, my first summer that was there, it was really, somebody asked us to do some work, and so I said, yeah, I'll introduce you to Mr. Sapp. And he said, no, I don't want him to do it, I want you to do it. And so that's kind of, we did that, and then of course, Mr. Sapp, of course, said, well, you can't work for us and work on, and so we said, okay, thank you very much. And how do I say this? This was not a career. I wanted to be able to pay for my days. And my brother wanted to go to college, and so it really was kind of, okay, let's begin. And all of a sudden, now it's been 51 years, and it's really been fun all the way through. Our first truck that we used to pick up our debris was I think it was a 1966 C60 Chevrolet. Now, for those of you that don't know, that's a 3/4 ton pickup truck. And it gets full really fast. And when you're in the tree business, when you're a tree service contractor, when your truck is full, you are out of business until your truck gets in. I mean, it's just, and so we got really good at getting our truck empty. And we actually bought our first one of those in 1972, pretty soon after we started. And let's go to the next slide. Okay, so we are still in the tree business. After a period of time, we're dumping 10 or 12 of those loads a day in the Gainesville area. And I think at that time we were they're charging us $2 to dump that load. That was in 1972. Over time, it got up and got more and more and more expensive, and so we got really good at doing other things. We'd go to farmers' places, and we'd pile it up in the middle of a field that they weren't using, and then it was rain, we'd light it on fire and that kind of thing. Well, in 1986, they passed the George Kirkpatrick recycling bill. Anybody remember that? Made everything we were doing with it illegal. You can't burn it, you can't bury it in the landfill, you can't do anything, there's nothing you can do. And so what we did was we started a company called Wood Resource Recovery. Now, as you can imagine, between 1971 and 1986, there is a lot of history, so there's a lot of that story that goes. But this is where we are. We started a company called Wood Resource Recovery out on 121, and I'm sure that people of you have been there, and we had no idea what we were going to do with this stuff. There were some people that helped us, and I think our first market for urban wood waste, is what we called it at the time, was Pride, who serves the prisons out in Brooklyn. And they had, they used wood-fired boilers to heat their water for their dishes and their showers and all of that kind of stuff. So that's where it first went out. And then, of course, Georgia Pacific and Palatka learned that we knew how to make wood chips, and then it went to Perry, and then went to Fernandina Beach, and so now all of this stuff is going out, and the material is coming in. Oh, by the way, when we got our permits and Levita Brown and the county commission helped us a lot getting that up and going, and just about the time we got permitted, we were the first state recognized wood recycling facility, what they call now yard trash. But we were the first recycling facility that was recognized by the state, And of course, as soon as we got recognized, then the city of Gainesville said, "Oh, by the way, will you take our curbside pickup stuff?" And then the University of Florida has said, "Hey, would you take our stuff?" And so now we're getting more and more and more stuff. And we thought we were going to have a little bit. Oh, and the site contractor said, "Hey, we have stuff we need to do with our," and so it's coming. And it's kind of amazing how during that period of time, we learned how we figured out sort of what to do with it and where to go with it. But as you can imagine, not everything that comes in is nice, clean, shiny, pretty stuff that they like. And so it's got crap all over it. And we didn't know what to do with that stuff. So it kind of got pushed up in what we call berms now, but it was piles around the edge of the area and nobody knew what to do with it. It just sat there over time, and then BFI decided that they needed to own us. And so they bought Wood Resource Recovery. And remember, the city of Gainesville and Alachua County curbside pickup was all going in with all of that. And so now we had a bunch of our stuff that is piled around there, and they had a bunch of their stuff that was all kind of piled up in what they were doing with it. And about a year after they bought us, they lost the contracts to manage the city of Gainesville and Alachua County. And so what they did was they spread everything out that was out there, closed the gate, and left.
Oh, wow.
Well, we're dumping 100 tons a day of tree services in tree debris with Gaston's Tree Service. Now there's a whole lot of history there. I've gone and I've done a whole lot of other stuff. My brothers continue to run the company, and I've done some other startup stuff. And anyway, when they brought me back in, and now I'm running other parts of the company and that kind of thing. But the whole idea is, Bill didn't have a place to dump his stuff. And so for a period of time, it was illegal and everybody knew it, but there wasn't any other solution. And so that's what they did. After a period of time, Bill finally found somebody in BFI that knew that they had the site that had the authority to sell it. You know how that goes. So, and I don't even remember when we are. Now we're back up to about 1990 maybe. Does that sound right, honey? 1990? And maybe. Yeah. No. 2000. Yeah. 1990, yeah, somewhere in there. But anyway, the whole idea with all of this is, and the reason that I'm telling you this is, you guys don't know who I am. And so I'm going to tell you some stuff that is really weird in this soil, in biologically diverse soil. And so why should you listen to me? Really? And that's kind of what all this is about. So now we own the property again. We're running it, and this guy from the University of Florida comes out and he says, "You know this crap over here that you don't know what to do with? That's like fertilizer." And so there are people who know what to do with that begin to come buy it, and we don't know what they're doing with it. But they are buying it, and it's going out, and I'm thinking, maybe we need to learn about exactly how to make turn this into a product. And my brother, now we're up to 2001, 2002, and my brother says, "I bought a blower truck." A what? A blower truck. We're gonna blow mulch in the flower bed. It works. Now, if you want to spend a couple $100,000 on a machine that will blow mulch in a flower bed, isn't it? Yeah, I said to him before we started. You remember I told you I had no idea what I was going to say, and when I do, I'm going to say way too much. Well, it's really kind of weird. All of these people that we go by and we look at their blower trucks, and they really talk about how great they are and wonderful, and then about 2 or 3 weeks later, they call us and say, hey, we got a blower truck for sale. Well, we ended up with that. But through all of that, we learned about a company called Filtrex. And Filtrex was using blower trucks to put compost in socks and filtering stormwater. 1,000% more effective than silt fence. And they had garden socks where they were putting compost in garden socks, and now used raised bed gardens in these garden socks, doing amazing things with it. And so I decided that was okay, it's time for me to learn how to compost. That's really when I got started with learning how to compost. And one of my very first meetings at the University of Florida, there was some ecologists there and some environmental engineers, and they were talking about all of the damage that chemical companies were doing to agricultural soil. I'm a tree cutter. You know what I mean? I mean, I'm thinking, these guys are crazy. They wouldn't do that. Well, anyway, I wanted to learn to compost. And so throughout the years, I've taken courses with the state of Florida. I've taken courses with the U.S. Composting Council. I've taken courses with the manufacture and utilization of compost in agricultural, all of those things. And everywhere we go, everybody's talking about how good it is to use organic material in agricultural properties and how you want to grow in organic stuff. And I'm not seeing it working anywhere. Now, have y'all heard that before? Farmers all over the place talk about how salesmen go to places and go to them and talk about how wonderful the next thing is going to be. And then they buy it and they put it out and nothing happens. How wonderful it is when you put compost on and you buy it and you put it out and you still got to throw a bunch of fertilizer on it. You guys have seen that, right? And I've seen that. But yard waste is a pretty good sized industry in Florida. In fact, all over the country it is. And we got to do something with it. And there's two ways to make it a pollutant. One is to open burn it, and the other is to bury it. And so what we're doing with it is better for the yard waste. But anyway, if I'm a farmer, I'm not going to buy a bunch of that stuff and put it on my ground if it's not going to do any better. If my farm is going to do as good if I continue to put chemicals on it. One of the things that I remember though in the 90s, anybody ever had a mentor named Bubba? Had a mentor named Bubba, and I remember him saying that relief is just a moment away is the worst phrase that's ever been coined. And so now we're all the way into 2020, 2021, and up pops this thing on my computer called the Soil Food Web. And it made sense. And I'm thinking, this is another class you're going to take. I will not tell you how many industries I'm certified in to do all kinds of crazy things. This is another class you're going to take. What do you do? And it was not inexpensive. But what they were talking about is how to really make a difference in soils and in organics. And so I clicked on it and I gave them my credit card and there it went. And say it again. Keeling? Keeling. Keeling is taking that course now. She has finished the foundation courses. You've seen this slide, haven't you? Mm-hmm. Yep. This is one of the first slides, and it makes sense. You have to think about, and it makes a whole lot more sense now than it did then. Soil is not dirt.
Right.
And dirt is not soil. If you've got a good soil, you've got good structure, and I'll explain to that a little bit. When you have nutrients in the soil, you don't have to worry about leaching. You know, we've got all kinds of stuff that's leaching through our stormwater into our lakes and into our ponds, and what are they, something called red tide somewhere. If you've got soil, you don't have that problem. Let me not say you. We don't have that problem, and we'll discuss that too. Water's retained, it moves so much more slowly through the soil, and when it comes out and ends up in the groundwater, guess what? It's clean. And so when we start talking about making soil instead of dirt, it's a whole lot more than growing plants. I need to say this to you real quick. I am not a grower. I grew up 3 blocks from City Hall in Gainesville. I've been telling people all my life, I hunt, fish, and farm at Publix. Brody, stand up. I got Brody when he was 9 years old.
Hello.
When I married his mother, Bobby. Brody has been certified as a golf course superintendent and a landscape design guy. He can grow anything. When he was not long after out of high school, he had a bonsai garden at my house that would blow your mind. Well, he got busy when work had to go out and do some other things, and we had to take care of it while he was gone. Guess what happened? So sorry about that. Anyway, but he has been helping me when I really finally got that I knew that I had some real quality soil. He's been helping me grow with it, and we're going to show you some of the stuff that he's been able to do with it. And so I'm now about 3 years out, and it's time to put up or shut up. And I've been talking for almost 20 minutes, and this is a 30-minute talk, so we got to go fast. So, healthy food web, and we talked about this a little while ago. A healthy food web will make nutrients available at the rates plants can require. And I'm going to tell you, this is the coolest thing in the world. The plants are in charge. They tell the food web what's going on. And while we're talking about food web, we're not just talking about soil. We're talking about the entire microbiome. We've already talked about not leaching, suppressed disease competition. We're going to see a picture of this that's going to blow your mind. Build soil structure and decompose toxins. It will do every bit of this. Every bit of this. This is ryegrass. Look at this. Planted in July in 2002. Harvested November 6th, 2002. And mowed twice to ½ an inch. Anybody ever seen a root system like that? I have seen hundreds of those slides. One of these days, soon, I'm going to say I did that. You've seen that, haven't you? 70% of the soil that was in place, 30% of what they call biocomplete compost, biocomplete T1s, no weeds, and no disease. Blow your mind. There are slides like this. I'm going to tell you a little bit about Dr. Ingham. Let's go ahead and go to the next slide. Dr. Ingham, Elaine Ingham, was a marine biologist. And I'm talking about 1982, 1983. I am just out of high school. No, 1972, 73. I'm just out of high school, and she is at the University of Texas working on her master's degree, and they asked them to study the oyster beds in Galveston Bay. the oysters aren't growing. So they go in and they figure out that they're missing there's a bacterial component that are missing. When they put that bacteria in, they start growing. 2 weeks later, they stop. So they do it again, and there's a whole story about using the right way to do the testing, because one testing showed it was no difference at all, but if they do it another one, it's like the world changed. And that's the way science is. You know, I mean, you really have to, you have to look at it from all the angles. So, but what happened was with all of this is that they determined that what was coming in was, there was something getting into these oysters, and it was coming down the river into Galveston Bay. Well, what's upstream in the river into Galveston Bay is the whole Midwest agricultural system. So she decided for her PhD that she wanted to study soil biology. So she goes all over the country saying, I want to study soil biology. I want to study, what does bacteria do in soil? And the quote was, nothing. Don't waste your time, don't waste your life. It's all about pH, NP, and K. Don't do it. Now think about this a minute. This girl has gotten, she's got her master's degree. What are you when you get your master's degree? 24 years old, 25 years old? And she's got these expert PhDs who spent their life in agriculture studying. These are scientists. These are the people who know. And she had the courage and the intuition to follow what she felt like and knew was right. Man alive. Have we done that? Think about that. That's really kind of impressive. All right, I want to show this, and I've only got a couple of these. You see the difference between this and this? These are two owners. These guys have gone to a biological farming. These guys have not. I don't know if you can see this, but this has been grazed 5 times since the season started. This has not been grazed at all. This is in April in 2011. You see this in May 2011, it looks like they've gotten some rain. This has been grazed 7 times. This still has not been grazed. You see the difference here and the difference there? Can you see how that fence goes up there? You see the difference, how that, all the way up? I mean, and I've heard farmers say, well, you can't do organics to scale. All right. While you go to the next one, while you go to the next slide, I'm going to tell you about a 10,000 acre cattle farm in Australia that they saved so much money the first year on vet bills that it completely paid for their conversion. Tomatoes in South Africa, 1 or 2 years production, and then they got to go 10 years fallow because of what tomatoes do to the soil. Now, I didn't know that. Did y'all know that?
Yep.
All right.
In South
After going to the, by the way, 18% production that was grade 1, which is the money, what they make their money on, and the total yield is 80 tons per hectare. Now, 100 hectare, right? Is that what it said? Somewhere? Well, it's not up here. Well, it's 100 hectares. That's 250 acres, by the way, for us. It's 250 acres. In the worst land, after converting to biological farming, they get 3 years production and then 1 year fallow. And in the best land, it's continuous production. They don't have to worry about it. The production of grade 1, which is the money-making tomato, goes from 18% to 50%. And then they go from 80 tons per hectare to 110 tons per hectare total yields, and they're expected to go to 120 when it gets full. Now, run those numbers. Run those numbers. All right, I'm going as fast as I can. It's 7:30. All right. By the way, you see this? Brody grew this. Now, this is all grown in what I call biodiverse premium compost. And there's very little of this. But what I've learned how to do is take the small amounts of this, inoculate large amounts of regular normal organics, and so now we go boom and we can scale it. All right. Yeah. What you can't see here, and I don't have a Brix meter, but what you can't see here is how deep these greens are, how much production he's getting, and how much nutrition that there's gotta be, because these plants are so healthy. Brody, when this picture was taken, how long had you had them in pots?
Well, that one that you were pointing at was a zucchini in a bonsai pot.
This one here?
Yeah. And it quickly ran out of room and came to its demise and died. But it wasn't at that time. I think it was like maybe 3 weeks old.
3 weeks old at 3, yeah.
Maybe
So he went from this to. So anyway, all right, let's go to the next one. And by the way, the reason why, I had to do that because I love that plant. So that's the same plant. So we can move on. But the reason I wanted to do this was I showed you things of what they're doing around the world. I wanted to show you what we're doing in Gainesville. All right? And yes, this is very small, and like my brother says, it's time to put up or shut up. So anyway, all right. Now, can anybody tell what's different about this picture?
That's a tomato hornworm covered in wasp eggs.
Yeah. Now, this is a
tomato
giant
hornworm.
hornworm.
Wasp eggs.
Now,
yeah.
this thing is probably about as big as my finger, and
Yeah.
it's probably about as big as my finger. And you can't tell that's not a leaf there if you can't zoom in. That looks like a leaf, but that whole thing is a hornworm. Now, what happens with these wasps? What kind of wasp is it? You don't remember? Okay, it's a wasp.
Arachnid, I think it's called. Brachnid, I don't know.
Yeah, that's it. It's a brachnid wasp. And what this wasp does is these wasps go in and lay their eggs inside the worm. Then the eggs hatch, the larvae eat the insides of the worm, kill the worm, and then they build cocoons on the outside of the worm. Now, this is cool. Now here's my question. What pesticide are you using to kill what, and how is it going to affect the hornworm or the wasps?
Exactly. Yep.
You know, we are all food for something, which is why they call it the soil food web. Now, everybody thinks it's food we're going to eat, and that may be what they mean, but when I think about it, we're all food for something. When we die, bacteria comes in, and fungus and protozoa, they come in and eat us up. So anyway, I explained this to a guy in Sunday school last Sunday. He was a farmer, and he said, "Well, I don't want a bunch of wasps around there." and this girl in the class said, "Well, think about the birds that eat the wasps, and then something eats the birds, and then So what happens is, when you've got a balanced diversity, you'll get something in there that gets out of balance, and then something will go and fix that and make it all better. And we're going to describe that a little bit more and more, and I'm going to do it as fast as I can. So let's go to the next one. And this is the cool part, and I'm only going to spend a minute here. You see the plant here? All right? The plants do exudates, and in a few minutes we're going to talk about exudates. Do we have any doctors in here? Any veterinarians in here? Anybody know what an exudate is?
Something that comes out.
Okay, yeah, that's not fair. You can't. Listen, I bet I've asked 500 people that in the last 3 years. Oh, yeah?
Yeah, it's some kind of stuff that comes out of a body.
Something that it's exuded, right. Yeah. A veterinarian told me that I was talking to Ted Yoho. He was the one guy that I asked personally, said, "What's an exudate?" He said, when a cow gets sick and he has something on him, it's like a fester or boil, and it exudes out. Well, here's what happens. This is like an orchestra. Any musicians in here? All right, this is like an orchestra, and the plants are the conductor. Because what happens when the plant germinates, or when a plant gets planted in here, they have simple sugars, and they exude it into the soil. And those simple sugars attract the bacteria. Now, what do the bacteria do? Bacteria eat simple sugars. But that's right. The simple sugars are exudated. But the bacteria then invite nematodes, and we're going to look at some of those, and protozoa, and fungi, and earthworms, and all the way up, and all of a sudden, all of the whole web comes to the plant, and the plant attracts what is needed by the kind of sugars that it exudes to bring the right bacteria. Different plant, different bacteria, different kind of soil. If you have a fully diverse soil, the plant will tell the biology what pH to go to. So we're testing NP and K, right? And pH. What are we not testing?
The biology.
The biology. Next slide. Okay, I'm going to read this. I have to read this, and there's another story, and I'm sorry. There's no way I can do this in it. Plants frequently have to weather both biotic and abiotic stressors. They have evolved sophisticated adaptation and defense mechanisms in recent years. Chromatin modifications, nucleosome positioning, and DNA methylation have been recognized as important components in these adaptations. Given their potential epigenetic nature, such modifications may provide mechanistic basis for stress memory, enabling plants to respond more efficiently to recurring stress or even prepare their offspring for potential future assaults. In this review, we discussed both the involvement of chromatin in stress responses and the current evidence on somatic, intergenerational, and transgenerational stress memory. Intergenerational and transgenerational stress memory in plants.
Yeah.
Who's heard the term epigenetics before? Okay, so everybody. All right, everybody knows. Bruce Lipton, when I was in junior high school, coined that term and demonstrating that we were not victims of our genes, that we directed and upregulated or downregulated our genes based on what we were thinking about. All right. I mean, when I read that, and I read that 6 months before I got cancer, and it changed the way I thought and changed the way I managed my cancer. And I have a better results than almost anybody I know that had the cancer that I had. I picked up a book called Biology of Belief. I had no idea. I thought it was a book about faith. And that's really what led me all here, and that's why I had to go through this. I was in third grade when my third grade teacher, now third grade, we're talking about what, 1963? My third grade teacher said, they've done a study. It's going too long, Tom, and it's just too bad if y'all have to go home, I understand. They've completed a study where, you know, they had kind of a new device back then called a lie detector. Remember that? All right. So they were putting that on plants, and then they were going to use cigarettes and cigarette lighters to see if the plants responded. Well, what happened was before they got started doing anything, after they hooked up, every now and then the plants would respond. So they decided they got to figure out what's going on here, and they found, not buildings away, but several classrooms away, they were putting shrimp in boiling water. And every time they were putting shrimp in boiling water, several classrooms away, the plants were responding. The Does that change the way you think about stuff a little bit?
It's all connected.
I mean, so, all right, let's go. All right, so what are exudates? We've already gone that. This is when I knew I was in the right place. That's a video. Hit the little thing on that. You got to watch this guy. Now, I named this guy Albert. He's in my microscope. This is the first time that I looked in my microscope and I saw something and it's like, wow. Now that's a rotifer. What does he look like?
Gator.
That's why he's named Albert, right? Now, what he's doing is he's eating 10,000 bacteria an hour. Now, they are not the greatest thing. A rotifer is a facultative anaerobe, and you don't want your soils to get anaerobic. But what he's doing, do you see where he's making channels through that soil, where he's opening it up for oxygen and for water to move there and hold through that? I mean, that's the coolest thing in the world, and that's when I knew that I was going to fall in love with this course. Let's go to the next slide. If you click next. All right. This is a little out of focus. This is an amoeba, and he's cool. We'll talk a little bit more about this. But this is a nematode. You know what I've learned about nematodes? There are more of these in the world than there are of any other animal. You got them in your body a couple of feet long, in your intestines. Yeah, whales have them 2 meters long. Now, what happens when we take broad spectrum antibiotics?
Kills all that stuff.
You know, I don't want to say anything about anybody in particularly, but glyphosate was patented as an antibiotic. And now they're spraying it on about 2/3 of our harvested material, and so we're eating. And we have these things in us. The thing I loved about this guy is his ornamental mouth. And I think that he's molting. I think that he's they shed their skin like snakes. Or, some of them do. There's a whole bunch of different kinds of things. Okay, let's go to the next one. But can you see why you would? Oh, yeah. By the way, this is and I'm not sure why I left that as a video. I think that there's something that runs through that later on. But go ahead and go to the next slide. I think there's a flagellate run. All right, now this is cool. Doesn't look like there's anything there, does it?
Press play.
All right, click play on this. You see that guy right there? That's called a naked amoeba. And I grew him. And he's basically doing the same thing. Now, what happens is you see that thing flying up there? That's called a flagellate, and we'll talk about them later. But he is not only eating bacteria, what he's doing with that bacteria is he's taking in way more nitrogen than he needs in order to get the carbon, or it's the other way around, I'm not sure. And so they call it the poop loop. So he's pooping that out, and that becomes available to the plants. That is okay. And then he's also food for other things. So let's go to the next one.
Stop. Here we go.
These are all soil samples, right?
These are all soil samples. Yeah, these all came out of my compost. Now,
Oh,
see
that's
that guy right
great.
there? Now, this is the one slide that I didn't do. I stole this slide. But you can see why. All right. That is another naked amoeba. And I call him the dancer. Maybe I ought to call her the dancer. But I love her. And these things are eating thousands of microbes an hour. All right, go to the next one. Oh, this other piece is a fungus here, and that is vital in our soils, and we'll talk about that later. This is another naked amoeba. This one I did grow, and not a naked amoeba. This is a stellate amoeba. All right, go to the next one. Click play. I don't remember what this is. Oh yeah. See this guy right here? Now, it's a little out of focus, and I think it'll get into more focus, yeah. This is called a stalk ciliate. A stalk ciliate is another one of those facultative anaerobes. They're not wonderful, but as long as you don't have too many of them, it's fine. But he's holding on to this micro aggregate over here with a flagellum, and then he's got like a buzzsaw here that you'll see later on a thing that I call bud. And it's swimming everything through and eating the bacteria like crazy. And these things are in our soil, and they're making a decision. Somewhere that guy said, I'm going to hang out here because the bacteria that I want is good and I can attract them. Now, do we ever think about our soil as making decisions? I know. Now you know why my family thinks I'm nuts. Go to the next one. All right, there's a story behind this. See the pear here? Anybody know what that is?
Pollen.
Huh?
Pollen?
It looks a little like pollen. I would not have known, I would not have even seen it, but I was out at Grow Hub, and they said, we're having a problem with root-feeding nematodes. Actually, they just said, we're having a problem with nematodes. If you're having problems with nematodes, by the way, you know that it's root-feeding nematodes. And there are only a few of those compared to everything else. But the female adult nematode looks like a pear. And she, about a third of her, burrows in to the root of the plant and then feeds. And then when she lays her eggs, or whatever it is she lays, they actually get injected into the plant. That's why most of the time when we go looking for root-feeding nematodes, we can't find them because they're all in the roots. But for some reason, I had one out there, and they've told me that that is a female root-feeding nematode.
That's cool.
Now, guys, I've got to tell you, that is just cool. Way up over there is another amoeba, and I circled that. But okay, let's go to the next one. All right. Now, I want you to go about halfway up here before you start it. And you grab that and move it and start it, because part of this is watching it. This guy here, this is a bacterial-feeding nematode. Watch this right up in here. What we're watching here when this gets started, well, we might as well just go ahead and do it. What we're watching here when this guy gets started is we're watching him, that mouth work, and it'll get in a little better focus here in a minute, and we'll be watching him swallow and go through the stomach and out. And I'm telling you what, guys, if they had taught me how to do this in the 8th grade, I would have had no life. I would have ended up being a lab rat. I mean, that's all I'd have ever done. So you see that? That is so cool. Okay, we can go to the next one. Yeah.
So wait, what is that?
What is it? Oh, that is a bacterial feeding nematode. And you want a couple of thousand of those into every gram of soil. All right, now this will go ahead and play this. This is a root feeding nematode, and what you'll see here, and if I was doing it, I could stop it. But in his mouth, there's a spear, and he gets up to the root, and then not the root, the fungus, and puts it into the fungus, and then dissolves the inside of the material that's in that fungus, and then can make that available to the plant. All right. All right, let's go to the next one. And I don't have a root feeding nematode in here. A root feeding nematode has that same thing, but it it has balls at the end of the spear. They're called these bulbs that, and what it is they're attached to very strong muscles that push out. All right, this is what I call a fungus ball. And the idea with a fungus ball is fungi will bring all of the micro aggregates of that soil together and make macro aggregates. And the idea here is, one is it expands everywhere so that it communicates with everything. And I first learned about, remember I'm a tree guy, so I learned about mycorrhizae, which actually means fungus roots. And the bigger the trees, the more kinds of stuff, the more mycorrhizae you need, and it lets everybody talk. What they've learned later is, by the way, the largest living thing in the world is in the Northwest, and it is mycorrhizal fungi, and that is the size of 1,600 football fields. And they can take trees that have these nutrients over here that have an excess of what they need over there, and they will move it in that fungus over here and provide it to the trees over here. Now, something is making that happen. What do you think that it is? I mean, think about this, guys.
Tree.
Huh? Yeah.
Tree.
Sugars
Huh?
from the roots,
Yeah.
exudates.
Well, yeah, very much. Yeah. So the idea with all of that is that the trees provide photosynthate to the fungus. 50% of the sugars that they make and the energy that they get from the photosynthate goes into the soil and exudates and into the fungus to provide the fungus with the nutrients that it needs. And the other 50% is in the leaves and the other stuff up top. But most of the action is in the soil. And that was just such a nice ball, I had to have it. That came out of my fungus as well. Now click on this. This is Buzz. Watch this guy. Now,
Whoa.
that is an animal that has made a decision.
Whoa.
That's super cool looking. I'm gonna play it again.
Well, you know, we're kind of long.
What is that?
I think that's a rotifer. And the reason I think of it is because of his mouth. He could be some other stuff, but he is attached on and remember, Albert was a rotifer too, but they don't look at at all alike. But they got different species of rotifers, just like they got other stuff. All right.
Back to road.
Next. Now this guy's stuck. He's dead. This is a microarthropod, and this is the next step up in there. And what they do is they eat the nematodes and the rotifers and the other stuff, and they have those in there like that, and that is the next step up. Okay, let's go on. So this is a picture of kind of what we had before when we talked about the whole soil food web, and I talked about it's like the plant is the conductor, and throughout here all you have fungus and bacteria and protozoa, and they are all working together. And the whole point about all of this, guys, is what are we testing for? And what I have learned with Dr. Ingham in the soil food web is that we don't need N, P, and K. There are 26 elements and the plants need them all. Oh, and by the way, we need them all. And so the way we're going to make healthy plants, the way we're going to make better tasting, more nutritious food is to measure the bacteria and the fungus and the protozoa in the plants. I have spent a a tremendous amount of my time over the last couple of years learning about this. And it has, you know, it has taken a while, and it's taken a while for me to kind of change my thinking. It's, as you can tell, it's changed the way that I think about everything. And it's time for us to make this work in Florida. And what I didn't want to do is I didn't want to go to the farmers, and I didn't want to go to the people that are buying compost and getting very basic results and really not doing anything better than that what they were doing before, and being another one of these guys, you know, take 2 of these and call me in the morning. And what I wanted to do, what I want to do, and I'm glad I'm only 40 years old. I'm about to start my 29th year of being 40, and what I want to do is I want to really make a difference in the way we do Florida gardening and agriculture. And the only way we're going to do that, in about 1974, I took a course in the Dale Carnegie's professional sales training course. And what I learned there was people do business with people that they like, trust, and respect. And what I've heard for my 50 years of dealing with farmers is, yeah, that stuff don't work. Yeah, that stuff don't work. And so I was not going to put something out there until I knew that I had something that would work. And I think that we've got it. And so over the next, let's go to the next slide. Over the next couple of weeks, I'm going to put together 20 cubic yards of this material. And I had all of this written down, and I had it in my notes that got left at home, and so I don't remember what it is. But a cubic foot of this, of premium blended compost at your garden centers is about $20 a cubic yard. A cubic foot. 1 cubic foot bag. That's a 1 cubic yard bag, or 27 cubic feet. Run $20 a cubic foot, and that becomes a pretty expensive bag of stuff. But it also works. And so what I'm going to do is I'm going to put together 20 bags of that over the next 2 weeks. I wanted to do it this week, but we've got the Florida Nursery and Landscape Garden Show this week. And I have to do it because I have to make sure it's done right. And what I'm going to do is I'm going to make 20 of those bags available at a 75% discount. And I don't even remember what that is now. But 75% of $20 a cubic foot times 27. And so I don't have my cards. I don't have any way for you to get a hold of me. You could probably find the name Gaston Tree Debris Recycling or Gaston Mulch and Soil, or mention my name. Levin said to get this. And what I'm going to do is I'm going to make up those 20 bags based on what is ordered. Because if we make a whole bunch of it up and it sits in the sun, it's all going to die. And by the way, if you take this home and it sits at your house, it's all going to die. All right? And so if you want, we will load it in your truck and let you take it home. Take it home, put it where you're going to put it, and keep it watered and that kind of thing, so that this stuff. Remember, you're taking home pets. All right, we brought in a couple of rescues. We have 2 4-pound dogs, and I'm telling you, it's like, oh, this is not like the gardening that we're used to. And so, you know, if you can't use a whole cubic yard, 2 or 3 of you get together, buy one, and then figure it out. Yes, sir.
So how much square foot would you spread that out on?
That depends. You know, which is always kind of in this. If you're gonna grow on the ground and you've got a pretty good soil and you haven't had a whole bunch of chemicals and stuff like that.
And let's say you don't have, my soil's pretty spent, so I was gonna go get a truckload of some good top stuff.
Yeah.
And add that to it.
I will tell you that Brody and I have split a cubic yard, and we've got them about a foot deep in a 3 by 6 foot raised beds, and we're growing pretty good stuff. It's not pretty enough yet. It's only been in there a couple of weeks. It's not pretty enough to show pictures. Yes, ma'am.
Could I cover it with pine straw to keep it
Yes.
moist?
Yes, you would still want to. You'd still want to water it from time to time. Put your hands in it, and
I'm getting
you'll.
rain where I am.
Huh?
I'm getting a fair amount of rain where I am.
Yeah, yeah, yeah. As long as you and if it's going to sit for a while, try to put it in some shade. Yeah. Okay.
So-
But yeah, cover it with what I did was y'all might not know this, but I have a little bit of extra mulch lying around for places like that. And so I put about an inch of mulch on top of mine.
Yeah, well, I'm gonna
Yeah.
put about 4 inches.
By the way, real quick, anybody in here ever buy a bag of mulch or a bag of colored mulch and you open it up, it's got a bunch of fungus in it? What are you supposed to do with that?
Spread it out.
Buy? Absolutely, that'll make all of your plants in there healthier, and by the way, help eliminate your weeds, because it'll change from ammonium nitrate to something else, ammonium.
Nitrate to ammonium.
Huh?
Nitrate to
ammonium. Yeah, yes ma'am.
That bag looks familiar. Is that what we use for some of the VFW gardens?
I don't know what that's called, a super sack, and you can tell, guys, I have done no marketing with any of this. I haven't done any preparation on this. I woke up this morning and decided I was going to do this.
But Tom, isn't that, did we,
I don't think we got any of that from you.
Okay.
We got the wood chips from
Oh,
you.
you?
Oh, good. I
Oh, yeah,
noticed
you
it.
did get some wood chips from
Okay.
us.
Yeah.
You might have gotten that from somebody else, but you didn't get
I
from
was
us.
gonna say, I thought we got something
Yes,
in
ma'am.
bags like
So,
that.
are you saying that we take it when we get this, or if we get this, could we just spread it on our garden?
Yeah.
And then cover with maybe some mulch?
Well, you could cover it in mulch.
And
If
then
you
plant-
spread it on your garden, what'll happen is if your garden is already pretty healthy and you don't have a bunch of chemicals in it, then the microbes will, in that, as it gets too hot and begins to dry out, it will go down and it will incorporate all of that kind of stuff together.
And then it will become
Yeah.
more of a.
The other thing that you can do, how many of you guys are already composting in your backyard?
Everybody.
Okay, you can take the stuff that you've got and make an extract out of that compost and water it and fortify what you've got. And so, and some of you guys, if you're making a pretty good compost, may not even need that. All right, yeah.
Can you just give a quick overview of what the process is for making a bag of that stuff? I mean, are you
Yeah,
just
is it-
piling it up and letting
Yeah.
it decay?
Is
at a
it
certain length
fungal
of time?
dominated or
Well,
bacterial
what we're
dominated?
doing is, guys, we're managing throughout the state of Florida about 750,000 tons of the urban forest a year. And so there is parts of this stuff that still is being put in windrows, and it heats up and it goes through the time and the temperature cycles and all of that. But because of where it is and how it sits, it doesn't get the biology. The biology doesn't come to it. It's not bad, but it's not great over time. And so I am doing a little bit about what some of you guys are doing is in my backyard right now, and I'm going to move it to some of our areas around the state, smaller piles where we're better able to manage the moisture, we're better able to manage the oxygen, we're better able to manage things, and then we can make sure that if it doesn't have enough nematodes, we can extract nematodes and put them in. If it doesn't have enough amoeba, we can do that and put them in. If it's got too many, those kinds of things. And then we take an inoculant from that, like I just told you before, and we'll take that inoculant and we'll put it in a cubic yard of material. And I want to do that a day or two before you come get it, not 2 weeks or a month or whatever, because I want that material to still be active and want you guys for it to work for you.
So your primary input is the carbon stuff,
That's correct.
Okay.
Now, one of the things that I have not said here in all of this is that really, in order for us to have an effective garden or we need 3 to 6% and closer to 6% organic matter to provide the food and to provide the aggregates and to provide the space that we need there.
Yeah.
The average soil in Florida is less than 1%. And
Yeah.
so that's one of the reasons why I think it is so important that we do it this way. So we're adding the organics and the carbon and the things that will make sure that all of this other stuff stays alive and survives.
Okay.
So do you actually
This
make
is
compost too as well, but not that particular compost?
Yes,
So if you were to get a pickup truckload of compost and then add one of those bags to the pickup truck, would that be a wise way to do it?
absolutely. Of course, that bag is gonna be about a pickup truck worth.
Oh.
I mean,
Well,
yeah,
you
if you
said
got,
you get
if
that
you,
bag.
yeah, if you got 10 yards of material delivered and had us deliver a bag with the 10 yards and blend it all together, that would work.
You said that's a
Absolutely.
cubic yard.
Huh?
That's a cubic yard.
That's a cubic yard.
Okay.
Yeah, that's 27 cubic feet.
So, just real quick, there's Gardner Supply Company. If you go to the Gardner Supply Company website, it has a soil calculator that will tell you exactly how many square feet in your garden 1 cubic yard will cover. Okay, so you can say my garden is 12 by 12. Okay, you can plug that in and it'll tell you how deep that will go and how far that will go. So Gardner Supply Company. Okay, soil calculator.
Can you stick around if people wanna ask more questions?
I will. I'll stick
Okay.
around if you've got any more questions. I mean, I'm only, I don't know, 30 minutes too long.
But just 33.
Yeah.
Okay.
Yeah.
So we're going to start the,
Thank you so much.
I'm not gonna record the questions.
start the raffle in